Hello everyone and welcome to Thinking Bee. Today we'll be starting a new series known as JEE Preparation, Sample Questions with Solutions. Today we'll be dealing with chemistry and the chapter Structure of Atom. Here's the first question. Energy of an electron which is moving in the orbit that has its radius 25 times the radius of the first Bohr orbit for hydrogen atom is. And we have four options. So let's see the information we are given. We are given that the radius of the orbit is 25 times the radius of the first Bohr orbit for hydrogen atom. Now, to find the radius for an orbit of principal quantum number n, it's given by n square into Rho, where Rho is the radius of the first Bohr orbit for hydrogen atom. Now here we're given that Rn is equal to 25 times Rho. So we get 25 Rho equal to n square into Rho. Comparing both sides, we get n square is equal to 25. This gives that n is equal to 5. So we have got the principal quantum number for the orbit. Now the question is asking us for the energy of the electron which is moving in this orbit. Now the energy of the orbit is given by En for the orbit is equal to minus 13.6 into z square by n square electron volt. Now we are talking about hydrogen atom, which is 1 square, and the principal quantum number which we found was 5, which is 5 square, which is minus 13.6 divided by 25 electron volts. But if we check the options, they are all given in joules, all of them. So I have to convert this into joules. Now 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. So minus 13.6 by 25 electron volts would be the energy would be given by minus 13.6 divided by 25 into 1.6 into 10 to the power minus 19 joules. So we have converted electron volt into joules. Now if we have to further simplify this, minus 13.6 into 1.6 would be minus 21.76 into 10 to the power minus 19 divided by 25. Now dividing by 25 is a hard task. So instead of doing that, we will first divide by 100 and then multiply by 4, or multiply by 4 then divide by 100, because the end result would be the same. Now if we do this, 21.76 into 4, 24, 30, 7, 8. We get minus 87.04 divided by 100 into 10 to the power minus 19. So division by 100 is very easy. We'll get minus 0.87 into 10 to the power minus 19. Or we can write this as minus 8.7 into 10 to the power minus 20 joules, converting into standard form. Now if we check the options, we get option D, minus 8.72 into 10 to the power minus 20 joules as the nearest option. So therefore option D is the correct answer for this question. Now moving on to the next question, we have the charge on the electron and proton is reduced to half. Let the present value of the Rydberg constant is R. What will be the new value of the Rydberg constant? R by 2, R by 4, R by 8 or R by 16. Now the thing we need to solve this is that the Rydberg constant is calculated as m into e raised to 4 divided by 8 e naught square into h cube into c, where m is the mass of the electron, e is the charge of the electron, E naught is the permittivity of free space, h is the Planck's constant and c is the speed of light. Now the question they've given us that the charge on the electron and proton is reduced to half. Nothing else have changed. So the new E dash would be E by 2. So with this, we need to calculate the new R. So let's say R dash. Now R dash would be m into E by 2 whole to the power 4 divided by 8 E naught square h cube c, which is equal to m e raised to the power 4 divided by 8 E naught square h cube c into 1 by 16, because 2 raised to 4 is 16. Now this whole thing over here is the original R, Rydberg's constant. So this new R dash can be written as R by 16. Now if we check at the options, we have option D, R by 16 as the correct answer for this question. So in here, the most important thing was knowing the formula for Rydberg's constant, which is m e raised to power 4 by 8 E naught square into h cube into c. Now, moving on to the last question. An excited hydrogen atom emits a photon of wavelength lambda in returning to the ground state. If R is the Rydberg constant, then the quantum number n of the excited state is A. root lambda r by lambda r plus 1, B. root lambda r minus 1, C. root lambda r by lambda r minus 1, or option D. root lambda r into lambda r minus 1. Now for this, we need to know the formula. 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square, where when an excited atom falls from an orbit for say n2 into orbit n1, what will be the wavelength? So here r is the Rydberg constant and lambda is the wavelength required. Now the question is given that the photon of wavelength lambda is returning to the ground state. Now ground state means that it's returning to the first orbit. So n1 is equal to 1. The principal quantum number would be 1. So doing this, we get 1 by lambda is equal to r into 1 by 1 square, which is 1 by 1 minus n2 square. So simplifying this, we get 1 by lambda is equal to r minus r by n square, and 2 is basically n. This is the only thing we have to calculate. Now we need n square, so let's isolate the term of n square in one side. So we get r by n square is equal to r minus 1 by lambda, which is equal to r lambda minus 1 divided by lambda. Now to find n square, we need to reciprocal both the sides. So we get n square by r is equal to lambda by r lambda minus 1. Taking r to the other side, we get n square is equal to r lambda by r lambda minus 1. So this gives n is equal to root of r lambda by r lambda minus 1. Now if we look at the options, we have option C, root of lambda r by lambda r minus 1, or r lambda by r lambda minus 1, basically the same thing. So option C is the correct answer for this question. So what we need to understand is that this formula 1 by lambda equal to r into 1 by n1 square minus 1 by n2 square, and also the fact that the ground state means it is returning to the first orbit. So that's all folks for this episode of JEE Prep. We hope you enjoyed this, and for more of such videos, please don't forget to subscribe to our channel Thinking B. Until the next episode, where we'll be dealing with other subjects such as physics and mathematics, stay safe, ta-ta, goodbye.